Hello and welcome everyone. Today in this question we are going to do the estimation of the hill road. Last time also we have done the estimation of the hill road, but in that question we have simply the depth of the cut and the depth of the fill given. But now in this question we have this ground level and this formation level given. So in our last video we have discussed all the steps for calculation of the hill road, and today we are directly starting this question. And we have to do in two steps. That is, in our step 1 we need to check whether it is the cut or fill by using this formula. But before doing this question we need to first calculate the depth. That will be the depth of the cut and the depth of the fill. So for this we need to make a table. So firstly we need to calculate the formation level, and we have this upward grade of 1 in 150. Simply remember that upward means positive, so this grade will be increased in each of these chains. It means that we have to make this table like this, and let's fill the value of this RL of the ground level in this vertical column. And we have this RL of this formation level at the chain edge of 0 as 507, and we have this upward grade at the rate of 1 in 150. It means that we have this 150 meter slope for 1 meter, and we need to calculate the slope for this 30 meter because we have this changes difference of 30 meter. Here we can see that 30 minus 0 is also 30, 60 minus 30 is also 30. So we need to calculate this upward grade for 30 meter slope. That means simply we need to do is 1 by 150 into 30. That will be 0.2 meter. And since here we have this as upward grade, we need to simply do is add this 0.2 in the previous RL of FL. So here we have this RL of formation level at the chain edge of 0 is 507, and to get the RL of formation level at the chain edge of 30 we need to do is RL of the previous formation level, that is 507 plus, because here it has upward grade and we have the value of 0.2, so plus 0.2, so we get 507.2. and again at the chain edge of 60 we need to do is RL of the previous formation level, that is 507.2, upward means plus, and we have the value of 0.2, so we get 507.4. Here also same method, that is RL of previous formation level, that is 507.4 plus upward grade of 0.2, so we get 507.6, and again the RL of previous formation level plus upward grade of 0.2. So here we have got all the RL of the formation level. So now we need to calculate the depth of the cut or fill. So for this we can simply do is RL of formation level minus RL of ground level, and if this comes in negative then it will be the depth of the cut, and if this depth will be in positive then it will be the depth of the fill. So let's start. So here we can see that this RL of FL is 507 and RL of ground level is 507, so we will get 0, whereas in this chain edge of 30 we have this RL of formation level as 507.2 and we have this RL of ground level as 507.95, so we get minus 0.75. Here we have this as negative, so it means that it is cut. Again we have this RL of formation level 507.4 and RL of ground level is 507.3, so it is positive, so it is fill. Again we need to do same thing, that is 507.6 is the RL of formation level minus 506.9. Here also it is fill portion, and again 507.8 minus 506.5, so it is positives. That means all these are the fill portion and only this portion is our cut depth. So here we have already calculated the depth of the cut and depth of the fill, but here we can see that at this chain edge of 0 we have the depth of 0, so we need to follow the same procedure in which our depth is 0. That means here we need to calculate the width by using the formula half of the formation width of the cut portion and half of the formation width of the fill, and it is again divided by 2, so that we get this small v. But here we have to use the r that is already given in our question, that is here we have this cross slope of 10, so we need to use the r equals to 10, And we can use the area of the banking as 1 by 2 b plus rd whole square by r minus s, and area of cutting equals to 1 by 2 b minus rd whole square by r minus p, in which this s means the side slope for banking and this p means the side slope for cutting, and this r is the cross slope for chain is 0. At the chain is of 0, we have this b equals to half of the formation width of the banking, that is 10 by 2, plus half of the formation width in cutting, that is 8 by 2, and we are going to take the average of both of these. So the half of the formation width at the chain is 0 equals to 4.5 meter. Let's check by using this formula, that is given depth minus half of the formation width at that chain is by cross slope of that chain is. So we have this given depth equals to 0. It means that we will always get this partly cut and fill. Depth equals to this given depth means 0 minus half of the formation width of that chain is, that is, it means this is the small b. So we have already calculated this small b equals to 4.5. So 4.5 and divided by the cross slope at that chain is 10. So divided by 10. So we get minus 0.45. So here we have this value less than equals to 0. So it is always partly cut or fill. So now we are going to calculate the area of banking, and here we can either put this plus or minus because this d is equals to 0, so it doesn't matter, but this s should be the side slope for banking. So here we have the value of b equals to 4.5 meter, cross slope equals to 10, and the value of side slope for banking equals to 2:1, that is s equals to 2. So let's put the value. So here we will get this area of banking as 1.266 meter square. Now we need to calculate the area of cutting, that is the area of cutting will be, instead of this plus there will be minus, and instead of this s we will use the side slope for cutting. So here we have the side slope for cutting, that is 1:1, so p equals to 1. So I can write this p equals to 1. The value of b equals to same as above, that is 4.5 meter, and the value of r equals to cross slope at that chain is, that will be 10. So let's put the value. So here we will get the area of cutting as 1.125 meter square. Now at the chain is of 30, we have this as minus 0.75 meter, that will be the cut portion. So we are going to do the same steps as before, that is, firstly we need to check whether it is wholly cut, wholly fill, or partly it is cutting or filling by using this formula. So we can simply use this formula, and at the chain is of 30 we have the depth of 0.75, and don't put this negative while using this formula. And here we need to use the formation width of cut because this is the cutting portion. So we have this formation width of cutting, that is 8 meter, but we need to put the half of its value, so we can simply write 8 by 2, whereas we have this cross slope as 12. Here we can see that we have its cross slope as 12:1, so r equals to 12, and while solving this we get its value 0.417 meter, which is greater than 0, and we have already discussed that when its value is greater than or equal to 0 there will be wholly cutting or filling. So to check whether it is wholly cut or fill, we need to see whether we have this as cut depth or fill depth. So here we can see it is a negative portion, that means it is a depth of cut, so we can simply use it is wholly cutting. Now we need to use this formula because we have this as area of cutting. So simply copy this formula, and in this value we need to put this s as the side slope for cutting, and r is the cross slope for that chain is, b is the half of the formation width at that chain is, d is a depth. So here at the chain is of 30 we have this r as 12, so here the cross slope will be 12:1, and its cross section will look like this, in which this portion is the depth of cutting. So we have this depth as 0.75 meter, we have this portion as side slope for cutting, and this is also side slope for cutting, in which we have side slope for cutting as 1:1, so this portion will be 1:1. So here simply we have the value of s, that is side slope for cutting, equals to 1, and we have this width, that is the half of the formation width for cutting, equals to 8 by 2, that will be 4 on both sides, and this depth of cutting is 0.75, and this cross slope at that chain is equals to 12, so we can simply write this 12. Now let's put this value in this equation. So while putting all these value, we get this area of cutting as 6.72 meter square. Now we need to calculate the area at the chain is of 60 meter. And here we have this depth of the field as 0.1 meter and this r equals to 10. So firstly we need to check whether it is wholly cut or wholly fill by using this same formula. So simply copy this formula. So at the chain edge of 60 we have the depth of 0.1. So depth equals to 0.1. So we have the depth of the fill. That means we need to use the half of the formation width of filling. So we need to use the formation width of banking, and we have this formation width of banking as 10 meter. So its half means 10 by 2. So we have this cross slope at that chain edge is 10:1. So r will be 10. And while putting this value, we get this as minus 0.4 meter, which is less than 0. So we have already discussed that if the depth or height is less than 0, then there will be partly cutting or filling. So I can write here as partly cut or fill portion. If we have partly cutting or filling, then there will be two cases, that is center line lies either in the cutting portion or center line lies in the banking portion. So we need to check whether the center line lies in cut or banking portion. So for this we need to see our question. So here at the chain edge of 60 meter we have the depth of the fill because this is positive. So since we have the depth of the fill, then the center line lies in the filling portion. That is, we need to use this case number 2 in which the center line lies in the banking portion. So here we have this banking as dominant, so this plus will be in this area of banking and this minus will be in area of cutting. We can simply copy this area of banking formula. And here the cross section at the chain edge of 60 will look like this. So this is our center line, and the center line lies in the banking portion because at the chain edge of 60 we have the depth of the banking. That is, this is the positive portion, and you can also find the length of this portion by using the cross slope. So we have this cross slope as r:1, that means horizontal is to vertical. So here we have horizontal value as 10 divided by vertical. And here also we can see in this small triangle we have this horizontal length unknown and let it be x, whereas we have this vertical distance as d, that is 0.1 meter. So we can simply do is horizontal by vertical. So we have this horizontal length as x divided by the vertical length is 0.1 meter. So on solving this value we can easily get the x equals to 1. So it means that this x equals to 1 meter. So here we can see that if this small length is 1 meter and this total length from this side to this side is 5 meter, then this portion will be 5 meter minus 1 meter, that is 4 meter. And here also we can see that this length from this side to this side we have 5 meter length, and when we calculate the length from this point up to this point, it will be obviously 5 meter plus 1 meter, that is 6 meter. Now we need to put the value of b, and here we have the value of b equals to 5 meter, that is from this point up to center line and from this side up to the center line, that is 5 meter. We have the value of cross slope as 10:1, that will be r equals to 10. We have this s, that is the side slope for banking, equals to 2:1, that is s equals to 2. And while putting all these value in this equation, then we will get this area of banking as 2.25 meter square. Now we can see that we also have this area of cutting. So now we need to calculate this area of cutting. So here we have this side slope for cutting, that is 1:1. So it means that this value of p equals to 1. At the chain edge of 60 we have this as the positive portion, that is, this is filling depth. So we need to use the formation with a fill. So we have this value as 10 meter. So the small b will be 10 by 2, that is 5. So b equals to 5 meter. And we have this value of r, that is cross slope at chain edge 60 equals to 10. So r equals to 10. And here we have this depth of the fill at the chain edge of 60 equals to 0.1 meter. So d equals to 0.1 meter. Now let's put the value in this formula. So while putting all these values in this above equation, we get this area of cutting as 0.889 meter square. Now we need to find the area of cut and fill at the chain edge of 90 meter. And here we have this depth of 0.7 meter, that is our fill depth, and we have to use this cross slope of 12. So here also we need to use the same formula, so you can simply copy this formula. So here at the chain edge of 90 we have the depth of 0.7. So depth equals to 0.7 minus, this is also the fill depth, so we need to use half of the formation width of banking portion. So here we have this formation width in banking equals to 10 meter. We need to use only the half of the formation width in banking. That will be 10 by 2. That is 5 meter. So 5 and divided by the cross slope at that chain is 12. So while solving this value, we get its value as 0.283, which is greater than 0. So if this depth is greater than 0, there will be wholly cutting or filling. But here this portion is the depth of the fill. So we will get the wholly fill portion, that is wholly banking portion. So here we are going to use this case number 1 because we have this as the wholly cut or fill portion, and since we have the fill depth given, that is we have the depth as positive, so we will be using this formula. And the cross section of the fully banking portion will look like this, in which this D means the depth of the fill. So we have this depth of the fill as 0.7 meter. So this D equals to 0.7 meter. B is the half of the formation width of banking portion. Capital B equals to 10 and the small b means 10 by 2, that is 5 meter. And here also B equals to 5 meter. And here we have the side slope for banking as 2:1. So this 2:1 on this side as well as this side, and we have this cross slope as 12:1. So this cross slope will be 12:1. So from this we can put the value of S equals to 2, value of small b equals to 5. This value of R will be 12:1. So R equals to 12, D equals to 0.7 meter. So let's put the value in this formula. So while putting all this value, we get this area of this banking or filling equals to 8.565 meter square. Now we need to calculate the area of cutting or filling at the chain is of 120 meter. So here at the chain is of 120, we have this depth of the fill, that is 1.3 meter, and we have the cross slope as 10:1, that is R equals to 10. And here also we need to do the same step, that is firstly we need to check whether it is cut or fill by using this formula. And here we have the depth of 1.3. So this given depth equals to 1.3 meter. So here at the chain is of 120, we have this as positive. So we are going to use the formation width of banking portion. We need to find out the half of the formation width of banking. So we need to use 10 by 2. So I can simply write as 10 by 2 and the cross slope equals to 10. So here we have this R equals to 10 and we get its value as 0.8 meter. So it means that it is wholly in banking portion because we have already said that we have this as the depth of the fill. So when we have the depth of the fill, then we will easily get the wholly banking portion. So it means that we need to use this formula. And here its cross section will look like this, in which this B is half of the formation width of banking and this D means the depth of the banking, that is 1.3 meter, and this is the side slope for filling on both sides, that is 2:1, and this is the cross slope of 10:1. So S equals to side slope for banking, that is 2. This small b is the half of the formation width of banking, that is equals to 5. We have the value of R, that is the cross slope equals to 10. And we have the depth equals to 1.3 meter. So let's put the value in this equation. So on solving this equation, we get this area of banking as 17.53 meter square. Now our next step is to calculate the chains at which the depth equals to 0. So here we can see that this is the negative portion and this is the positive portion. So between these two values there lies 0. So we need to find the chains at which our depth equals to 0, and we need to calculate the area for cutting and banking at that balance point. But here we can clearly see that this portion is already 0 and this is minus 0.75. At the chains of 0, we have already calculated the area of cut and the area of banking, so we don't need to interpolate in these two values. So here we have this as 30 meter chains and we have this as 60 meter chains, and we can see here that between these 2 points there lies 0, that is the depth equals to 0 between these points, and we are going to find that point at which our depth equals to 0. So here we have this as the cutting portion at the chains of 30, so its depth equals to 0.75. So this depth is 0.75, and at the chains of 60, that is this point, we have the depth of 0.1 meter. And here we can see that this is fill and this is cut. So firstly we are going to use this formula, that is R equals to 2R1 R2 divided by R1 plus R2, in which R1 is the cross slope of 30 meter chains and the R2 is the cross slope at 60 meter chains. So we are using this R1 equals to 12 and R2 equals to 10. So let's put the value. While putting the value of R1 and R2, we get this R equals to 10.9, that is nearly equals to 11. So it means that this cross slope equals to 11:1. Now we need to find the value of this B, in which this B1 means the formation width of the cut and B2 is the formation width of banking. So here B1 equals to 10 and B2 equals to 8. So let's put the value. So while solving this value, we get this value of B equals to 4.5 meter. So it means that here in this figure we have this B equals to 4.5 and here also B equals to 4.5. Now we can easily find the value of this area of cutting and filling. So you can simply use this formula 1/2 B plus RD whole square by R minus S, and here you can either use plus or minus. It doesn't matter because the value of D will always be 0. So you can simply use plus now. So here we have already calculated this B. That is, by using this formula we get this value equals to 4.5 meter. So we have already calculated this cross slope, that is 11. So R equals to 11. We have the side slope for banking, that is 2:1. So S equals to 2 and the depth equals to 0 meter. So let's put the value in this equation. So when you put all these values in this above formula, then we will get this area of banking as 1.125 meter square. Now we need to also calculate this area of this cutting. So let's put the value of area of cutting. So here we have this area of cut equals to 1/2 B minus RD whole square by R minus P. So here we have this P as a side slope for cut. So P equals to 1. The depth equals to 0. The value of the B equals to 4.5 meter, that we have already calculated, and the value of R is also 11. So let's put the value. We get the area of the cutting as 1.0125 meter square. So now we need to calculate the chains at which this depth is 0. So for this we have this as our 30 meter chains and this is our 60 meter chains. So this total length will be 60 meter minus 30 meter, that is equals to 30 meter. So we are going to find this length, that is, let it be x, and this length will be this total length 30 minus this portion, so 30 minus x. So for this we are going to use the similar triangle properties, that is, here at the chains of 30 meter we have this depth of 0.75, whereas at the chains of 60 meter we have this depth of 0.1 meter. So simply we need to do is horizontal by vertical. So in this triangle we have the horizontal length of x, so simply x divided by the vertical length is 0.75, and similarly in this triangle we have the horizontal length of 30 minus x, so simply 30 minus x, and divided by the vertical height is 0.1 meter, so divided by 0.1. So when we solve this equation we get the value of x as 26.47. So it means that this length will be 26.47 while this length will be this total length 30 minus 26.47, that will be 3.53. So we are going to calculate the chains at this point. At this point we have the chains of 30 meter. That means to calculate the chains at this point we need to add 30 plus 26.47. So we are going to simply write that this is at the chains of 26.47 plus 30, that would be 56.47. So at the chains of 56.47 meter, we have calculated all these area of the banking and area of cutting. So now we need to make a vertical column like this, and here we need to put all the chains, and here we need to also insert row in which our depth is 0. So here we have already calculated that at the chains of 56.47 we will have the depth of 0. So we need to also insert the column for the chains of 56.47. We need to put the value for area of cut and the area of fill. That is, here we have just now calculated that at the chains of 0 we have the area of cutting as 1.125 and the area of banking as 1.266, whereas at the chains of 30 we have the wholly cut portion. That means the area of banking will be 0. And we need to fill all the column. Now we need to calculate the mean area of cutting, that is the average of these two will be written here. So our area will be 1.125 plus 6.72 divided by 2. We will get mean area for cut, and again the average of this and this will be written here. So the area will be 6.72 plus 1.0125 divided by 2. And similarly, average of 1.0125 plus 0.889 divided by 2. And here we need to take the average of this 2, that is 0.889 plus 0 divided by 2. And here the average of 0 and 0, that will be 0. And here also we need to take the average of this 2. So let's calculate 1.266 plus 0 by 2. And here we need to take the average of 0 and 1.125. And here we need to take the average of 1.125 and 2.25. So 1.125 plus 2.25 divided by 2. And here we need to take the average of 2.25 and 8.565. And here we need to take the average of this and this. So we have calculated the mean area for cutting and banking. Now we need to calculate the length. So the length will be simply this chain is minus this chain is, that is the length will be 30 minus 0, that is 30. And here the length will be 56.47, that is this chain is minus 30, so 26.47. And here 60 minus 56.47. So here we have this 90 minus 60, that is 30. And again 120 minus 90, that is 30. Now we need to do is volume equals to area into length. So here we need to multiply this mean area of cutting into length. So this cutting area into this length. Again here this cutting area into this length. And here also this mean area of cut into its length. And same process here, this area into this length. And here also same process, this area into this length, that will be 0. And here also we need to do the mean area of banking into length. So mean area into length. Here also it's mean area of banking into the length. And same process, this area into length. And here also this area into its length. This mean area into 30. So we have easily calculated the quantity for cut and the quantity of banking. So let's calculate the total. So we can easily add all these volume for cut and the volume of fill. So we get 236.7 cubic meter, and this volume of banking equals to 593.4863 cubic meter. So in this way we have completed the estimation for the hill road. So if you like my video, please do like, share and subscribe.